Well, here we are at home, and I'm going to do a demonstration, a very common chemical reaction with vinegar and baking soda. And just to show you what happens with this, I'm going to pour a little bit of vinegar into a cup and then into the glass. And we have a nice wine glass here, but this is not wine that we're going to make. We're then going to pour some baking soda into this very gently, and we'll show you what happens. And it starts bubbling up quite a bit, and it may be getting out of control here a little bit. There we go. We'll add a little bit more baking soda, and I think it is, we don't want it to overspill. But as you can see, this is a very powerful reaction, and we'll be showing you on the computer what the reaction really is. Vinegar is acetic acid, or at least a very weak type, and the baking soda is sodium bisulfate, sodium bicarbonate, I'm sorry, which is a very common base, and it's used in baking and everything else. Let me just read you what you saw here is very important for this. On the package itself, it says, ask a doctor or pharmacist before use if you are taking a prescription drug antacids or may interact with certain prescription drugs. Stomach warning. To avoid serious injury, like a hole in your stomach, do not take until powder is completely dissolved. It is very important not to take this product when overly full from food or drink. And in the other part of this recording, and actually in the directions document for things to do, I'm including a link which will show you what happens if you do this experiment in your stomach. It's not very good. Well, as we will also show, one of the products of this reaction is basically carbon dioxide. This reaction forms sodium acetate plus an acid, and then it forms carbonic acid, in fact, the stuff you see in soda. In fact, if you look here, it's in little bubbles. And sodium acetate is the salt that it forms, and carbon dioxide. The carbonic acid breaks down into carbon dioxide and water, just like it does when the fizz goes out of a soda. So what we're going to do now, if we don't burn the place down, is I have in this case it's a glass measuring cup, and I have a candle in there. I'm going to light the candle, and I'm going to make carbon dioxide by reacting some more baking soda, sodium bicarbonate, with vinegar. So let me get some vinegar ready here to use. There's my cup, and this is just regular vinegar like you'd put on a salad. And we're going to make this like that, and hopefully we'll make enough CO2 to put the candle out, because CO2 is heavier than air. So the first thing I'm going to have to do is light the candle, and I'm going to do that now. And here we go, we've got the candle lit. We're going to make the reaction. And we're going to see if the gas, look at this, it's already doing this. You can see the effect of the gas come down, the CO2. And we're not quite making enough here, so we're going to put some more in here directly from the and we're going to see if we can't put the without spilling any of the liquid. It's a tough time to put this candle out. I used too big of a vessel. So we are going to go for broke. We're going to put the whole thing in. Whoops. Here we go. Going for broke. Well, it didn't quite put it out, so that didn't work. But if I had different size containers, it would put it out. That's what I'm going to do now. There. I don't want to set off any alarms here. But you could see the candle started wavering. Some of the CO2 was hitting it. And before I burn the whole place down, I'll call it quits. Thank you. Okay, we are now going to explain what happened, or more, what should have happened, with some graphics here. What we were combining was sodium carbonate, or actually bicarbonate, means it has two carbonates, and acetic acid. And I have just found out, between shooting these scenes, what went wrong, why the reaction didn't produce enough carbon dioxide to snuff the candle. And it turns out the bottle of vinegar that I bought was not only old, but it says it was diluted to 5% acidity, which is good for your stomach, but it wasn't the full potency of acetic acid that we needed to do this correctly. It fizzed somewhat, but it didn't do very much. So let's just chalk it up to a bad campaign and or cameraman and move on. The sodium bicarbonate and acetic acid reaction, known as baking soda and vinegar, involves sodium bicarbonate, NaCHO3, plus HC2H3O2, which is acetic acid. These are the two reactants, the two chemicals that react together. And the products are sodium acetate, this is the formula for it, and carbonic acid. This is the formula for carbonic acid. The carbonic acid then decomposes itself, just like fizz disappears from a soda. The carbonic acid becomes weaker to water and CO2. And that is what happens all the time. Now, in a typical acid-base reaction, which is what this is, the sodium bicarbonate is a base, and the vinegar is the acid, acetic acid to be exact. Unfortunately, the stuff we used was too dilute. Titrations, or mixing, of these acids and bases will result in water and a salt. The salt in this case is the sodium acetate. So when you mix a base and an acid, you always get water and you get a salt left over for any of these reactions. And that's what we saw. Now for the candle snuffing, air is about 80% nitrogen in the form of the diatomic molecule N2, and about 20% oxygen, or O2. If we do the arithmetic, air would have a mass, a molecule of air would have a mass of about 17.6 atomic mass units. That's if we weight the nitrogen at 80% and the oxygen at 20%. And the carbon dioxide would have a mass per molecule of 24 AMUs. So it has more mass, and therefore it's heavier than air, and it would fall out of the glass theoretically and snuff the candle. Actually, we just got enough carbon dioxide to go down in the glass and make the flame flicker a little bit, but it didn't quite put it out. Now I put in small print, you probably can't read it, is for use as an anti-acid it's good, but for CO2 production it's bad. In other words, if you were to have too much acid, you put too much vinegar in your salad and you got acid indigestion, and you want to mix a base with it, and you had some baking soda around, or bicarbonate, sodium bicarbonate, and you took a few teaspoons of it, although I'm sure it wouldn't taste too good, that reaction of all that fizzing and producing of CO2 would happen in your stomach, not in the glass as we showed here. And that could kill you. So what I'm including with the master document here is a link to a New York Times article where that very thing happened. And you can read all about it yourself, and I'll probably wind up asking a question about that.